What if I told you, right now, at this exact moment, the sun just fired off a massive M5.9 solar flare, strong enough to disrupt radio waves, scramble navigation signals, and send a storm of charged particles racing toward Earth? Because that's exactly what just happened, and the United States has officially issued a space weather alert. On the morning the alert was issued, nothing on Earth looked different. The sky wasn't flashing. The oceans weren't boiling. People were driving to work, scrolling on their phones, sipping coffee, unaware that 93 million miles away, an explosion had erupted on the surface of the sun, a blast so intense it could fit multiple Earths inside it. But scientists noticed, and when they did, they moved fast. The National Oceanic and Atmospheric Administration, NOAA, through its Space Weather Prediction Center, confirmed the detection, an M5.9 class solar flare, one of the strongest solar outbursts in recent months. Almost instantly, they upgraded space weather conditions and issued an alert to aviation networks, communication systems, and agencies monitoring power grids. But why does this matter? And what exactly is an M5.9 flare? To understand that, we need to go back to the sun itself, a gigantic, boiling sphere of plasma, constantly shifting, twisting, and folding its magnetic fields like a cosmic knot. When these magnetic lines snap suddenly, all the tension releases at once. The result? A solar flare. A burst of energy that shoots out into space at the speed of light. Solar flares are classified like earthquakes. A, B, C are small, M class are moderate to strong, X class are monstrous. An M5.9 flare is no small event. It sits right below the highest danger zone and can produce serious impacts depending on the direction of the blast and the strength of solar activity that follows. When the flare erupted, satellites orbiting Earth immediately detected spikes of X-ray radiation. Radio operators in certain parts of the world reported shortwave blackouts. Pilots flying transpolar routes received warnings. And across the United States, systems responsible for monitoring infrastructure entered a heightened state of awareness. The sun is currently approaching the peak of its solar cycle 25, a period when activity ramps up dramatically. During these peaks, flares, coronal mass ejections, and magnetic storms become more common. Historically, these cycles have produced everything from the spectacular auroras seen in May 2024 to serious disruptions like the 1989 Quebec blackout. So the big question is, could this M5.9 flare cause something similar today? The immediate effects, the first thing people noticed, was not visible to the naked eye. The flare's X-ray output ionized the upper layers of Earth's atmosphere, the ionosphere, which is crucial for radio communication. When solar radiation slams into it, the structure changes temporarily, absorbing or deflecting radio waves. Within minutes, NOAA confirmed radio blackouts across portions of the Pacific and parts of the western United States. The outages were not catastrophic, but strong enough to disrupt high-frequency communication used by pilots, emergency services, ships, and military channels. GPS accuracy also fluctuated. When charged particles interact with the ionosphere, position accuracy can drop dramatically. A self-driving car, a drone, or even your phone's navigation could suddenly drift several meters off course. But there was something even more concerning. A possible Earth-directed CME solar flares often accompany something even more powerful, a coronal mass ejection, or CME. While a flare is a flash of radiation, ACME is physical matter, billions of tons of solar plasma and magnetic fields ejected into space. If that cloud of plasma hits Earth, the results depend on its speed and its magnetic polarity. NOAA confirmed that coronagraph instruments on board the SOHO spacecraft detected a large ejection shortly after the flare. Analysts then began modeling the trajectory. Was it headed toward Earth? Was it going to miss, or was it glancing enough to cause geomagnetic disturbances? Early estimates suggested a partial Earth-directed component, meaning some of that plasma could reach the planet within 24 to 48 hours. If so, we may experience stronger radio disruptions, satellite drag in low Earth orbit, GPS scattering voltage irregularities in power grids, auroras shifting farther toward the equator. Geomagnetic storms are graded on a scale from G1 to G5. Even a G3 can cause widespread impacts. A G5, the strongest, has the potential to cause national-scale blackouts. At this point, you might be wondering, how fragile is our technology really? More than ever, modern civilization runs on satellites, GPS, communication systems, interconnected power grids. All of these rely on delicate electronics that can be overwhelmed by charged particles from the sun. In fact, recent studies show that as we increase our dependency on global digital infrastructure, our vulnerability grows exponentially. A solar storm that might have been a minor nuisance in the 1980s could be far more disruptive today. But here's the good news. Agencies like NOAA, NASA, and the U.S. Air Force Space Weather Operations have vastly improved their prediction models. They can track storms, warn pilots, advise power companies, and help satellites shift into safer configurations. That's why this alert was issued so fast. Because preparation is everything. Why this flare matters more than others: this isn't the first M-class flare we've seen this year. Far from it. But this one matters because it comes during a period when the sun's magnetic fields are entering their most chaotic patterns. Sunspots, dark, cooler regions of intense magnetic activity, have multiplied dramatically in recent weeks. Some of these sunspot clusters are enormous, many times the size of Earth, and these are the regions responsible for the most violent eruptions. The flare came from one of these massive regions, a complex magnetic structure with twisting fields capable of producing even stronger X-class bursts. This M5.9 flare might be a warning shot. Scientists are watching closely because where there's one big flare, there are often more. Could we see an X-class flare soon? Absolutely. And that's why this alert isn't just about what already happened, it's about what could happen next. Historically, periods of intense solar activity produce flare clusters where several eruptions occur in rapid succession. If one of those becomes an X-class flare aimed at Earth, we could face wide area radio loss, severe satellite disruptions, longer GPS outages, airplane reroutes, strong geomagnetic storms, auroras visible far beyond normal latitudes, and in a worst-case scenario, something extremely rare but scientifically possible. A storm on the scale of the 1859 Carrington event could occur again. That event fried telegraph systems, caused sparks to fly from wires, and lit up the global sky with auroras. But today, with our technological dependence, it would be a different story. Power grids could overload. Data centers could go offline. Satellites could fail. The internet itself, depending on region, could face serious complications. This is why tracking solar weather isn't science fiction. It's national security. It's aviation safety. It's communication stability. It's our modern world's lifeline. What happens next? Over the next 48 hours, scientists will monitor CME arrival time fluctuations in Earth's magnetic field, satellite telemetry, ground-based magnetic readings, radio frequency behavior. If the geomagnetic storm intensifies, additional alerts will be issued. But it's also possible that the flare's energy disperses, that the CME glances past Earth, or that effects remain mild. This uncertainty is what makes space weather so fascinating and so important. The bigger picture, solar cycle 25, is turning out to be much more intense than early predictions suggested. Sunspot numbers are exceeding expectations. Flares are growing stronger. Auroras are being reported farther south than they have in decades. Earth is entering the storm season of space, and this M5.9 flare is part of the pattern. In the coming months, scientists expect more M-class flares, multiple X-class flares, several Earth-directed CMEs, potentially powerful geomagnetic storms. This is not a cause for panic, but it is a reminder that our planet is not isolated. We're part of a living, breathing solar system governed by forces far larger than ourselves. And when the sun speaks, Earth listens. If you want more breaking updates on solar activity, space science, Earth changes, and the mysteries of our universe, make sure you hit subscribe. Turn on notifications so you don't miss the next solar flare alert, space phenomenon, or deep dive story coming your way. Thanks for watching, stay curious, stay safe, and I'll see you in the next video.